Okay, we are live, guys. So, first of all, similar figures. So we want to write this down. They're going to have the exact same shape. They're going to have the same shape. Okay, same shape. Same shape, but they'll have different sizes. Same shape, different size. So you might have one triangle that's much bigger than the other triangle, but they're going to have the exact same shape, right? If they have the same shape, then corresponding angles are equal. Okay? Corresponding angles are equal. So if I go back to my outside triangle, I know that this angle is equal to this angle. If they have the same shape, the angles must be equal. I know that this angle is equal to this angle because Ben, will you stop talking, please? Corresponding angles are equal, and I also know that this angle must be equal to this angle. So, for example, Ben, calm down. Calm down. You're on tape. I can send this to your mother. Okay? Now, if this angle were, say, 40 degrees, then I know this angle has to be also 40 degrees. If I know this angle is 50 degrees, then I know this angle must be 50 degrees. Same shape, just different size. If they're the same shape, then the angles must be the same. All right? Yes. 40, 40, 50, 50. Now, Tim said something also about ratios. So if they are similar, one could be twice as big as another, or the other could be half as big. So then we know that they have a ratio, and the ratio has to be the same for each side. So we're also going to say that the sides are proportional. If the sides are proportional, then they'd have the same scale or ratio. Okay? Thanks, Tim. Now, let's take a look at our example down here. We have two triangles. I have triangle ABC and triangle DFE. All right? Now, we're going to say we notice that if they are similar, angle C corresponds to angle F, angle A to angle D, and angle B to angle E. Now the two triangles are not equal, but we're going to say this. Very important. I want you to write this down. We're going to say triangle A, B, C. And we're going to use this symbol right here. You watching? That symbol means similar. That little squiggly sign means similar, okay? Now, Now the two triangles are not equal or congruent, but they are similar. So triangle ABC is similar to, now A corresponds to D. A goes to D, so D has to go here. So A goes to D. B goes to E, and C goes to F. So the letters absolutely must be in the same order. I know angle A corresponds to angle D, angle B to angle E. Now what would not work, not work, triangle ABC, similar to triangle, if I said triangle FDE. That is not true because A does not go to F. You don't write it that way. You have to put the angles that go together. A goes to D, right? B goes to E, C goes to F. So when you write it, you have to write it in the correct order where each angle goes to the correct angle, right? Now, we're also going to say that the sides are proportional. So DE, this side, everybody watching? Everybody watching? DE, this side, absolutely must correspond to AB. They go together, don't they? So DE goes to AB. We also know that EF absolutely must go to BC, right? Has to. And we know that FD absolutely must correspond to CA. So the corresponding parts must go together, and they make a fraction, which is a ratio, okay? So let's take a look. Okay, let's go to page 263. Go to page 263, all right? Now, if I take a look at example 1, we can take a look at the two rectangles. I know they're similar, so because we're told they're similar, so what I can do is say this. I know the 3 corresponds to the 2. Do you guys agree with that? The 3 corresponds to the 2, and the 7 corresponds to the x, right? So we're going to set up a fraction. I'm going to say, okay, the 3 goes to the 2, right? This side goes to this side. Everybody agree with that? They go together. That side goes to the side, and my 7 goes to my x. Now I have to be careful because you said x to 7. So I went big, listen, big to small, so then the next fraction needs to be big to small. Yeah, you have to be correct in the way you put it together. If you did it the other way around, you'd get the wrong answer. So the 3 goes to the 2.
Why is it big to small? You have to go big.
Nope, you can go small to big. So you can.
Make sure they focus.
Nice question. So you could also go 2 to 3 equals x to 7, right?
I think that looks more like.
That's probably easier to solve, isn't it? Both work. As long as you're consistent. Big to small or small to big, you just need to be consistent. Okay, so to multiply, to solve for x, I'm going to multiply up the 7. Because, Michael, I liked your way better. I get a 14 divided by 3 equals x. 3 goes into 14, 4 and 2/3. And that's the value of that side is 4 and 2/3. So here's how it works. You set up your fraction, and then you cross multiply. You set up your fraction. When you set up your fraction, you must be consistent, either big to small, or small to big, small to big. But don't mess it up, big to small, small to big. That'd be messing it up, okay? Be consistent on how you set it up. So example 2, okay? Now this triangle here is written a little bit backwards. If I rewrote this triangle, so it's a little easier to see, the 8 actually is down here, isn't it? And the x is actually here, and the 12 is here. I just took this triangle, and I turned it around, okay? It's easier to see if I turn it around, because then I can see for sure that the x goes to 25, and the 12 goes to 30, and the 8 goes to 20, right? If I need to solve for x, there's lots of ways to do it. Lots. Listen. X goes to 25 as 12 goes to 30. Listen. X goes to 25 as 8 goes to 20. Listen. These are all correct ways to do it, okay? 20 goes to 8 as 25 goes to x. These are all correct ways to do it, okay? We could do 8 goes to 30 as 25 goes to x. These are all correct ways. Any of those will work as long as you do it the right way. Big to small, or small to big, right? I did. I rotated it so that it was easier to see, right? So I like to write down and put the x on top. If I can put the unknown on top, it's faster to solve. Does that make sense? So if I go x goes to 25, because these two sides do go together, don't they? As 8 goes to 20, then that should be easy to solve. So remember, I went small to big, okay? Because I want to make sure that it's easy to solve. Bijou, put your phone away. Okay? So then if I multiply up to 25, I'll go x is equal to 8 times 25 divided by 20. And I'm just going to use my calculator. 8 times 25 divided by 20, and I get an answer of 10. Okay? Does that seem pretty easy? Okay, now, let's look at 3 through 8, and we'll be done in just a bit, okay? So, there, yes.
How did that one look so much different from the last one?
It didn't. It just had more numbers for kids to look at, that's all. More options, Cody. That's the only difference. You just had more options to solve it. And I went through many options, okay? Let's take a look at number 3. So they are similar. There's my symbol. They are similar. So find the scale factors. Find the scale factor. Then let's take a couple of sides we know. For instance, I might say 3 to 2. These two sides go together. You see that? So the scale factor would be 3 to 2, or that's big to small, or 2 to 3. Both are correct. It depends on whether or not you want to say, I'm going to start with the big triangle, or the big figure, to the little triangle. Or Or if you say, no, Mr. Davies, I want to go from here to here. Doesn't matter. They're similar. So do you want to go 3 to 2, or do you want to go 2 to 3? It does not matter. It's a scale factor of either 2 to 3 or 3 to 2, depending on how you look at it. Cody, question.
The question is asking.
From this one to this one, yes. So we're going to take this one, but I want to let kids know that it's okay to go the other way, okay? So it does say from this figure to this figure, so we're going to go the, oops, I circled the wrong one. 2 to 3, there you go, sorry. So ABC, so I'm going to go, they are asking us to go small to big. From A, B, C, D, E to K, L, M, and P. This one to this one is a factor of 2 to 3, okay? Find the scale factor of big to small. Now they're saying the other way around, okay? Which is going to be my 3 to 2. And again, it doesn't matter which way you go. When you solve it, both will work. It's a matter of, do you want to start with this triangle, big to small, or do you want to go small to big? Now, to find the values of x, y, and z, okay, first of all, x, if I set up my scale factor, if I want to find x, I'm going to go big to small. I'm going to go, I know, watch, it's this easy. 3 goes to 2, right? As x goes to 1. Do you see that? 3 goes to 2 as x goes to 1. Do you see that? 3 goes to 2, because I'm taking the parts that go together, as x goes to 1. So I'm going to set that up. 3 goes to 2 as x goes to 1. Does that make sense? 3 goes to 2 as x goes to 1. Well, that's easy to solve. X is just equal to 3/2, right?
Yes.
Or 1.5. So x equals 1.5. Now, let's look at y. Here's y, right? So y, again, we're going to go, y goes to 3 square root of 2 as 3 goes to 2. One more time. I went this side goes to this side as this side goes to this side, okay? Y goes to 3 square root of 2 as 3 goes to 2. Okay, so this side to this side as this side goes to this side, right?
Bottom one as well, you don't have to do that. Just
Yeah.
half side.
So let's multiply this up here, and then y is equal to 9 square root of 2 divided by 3. 9 square root of 2 divided by 2. Yeah, if I want a decimal, I can, but I might leave that answer. Yeah. So if I use a calculator, I go 9 square root of 2 divided by 2, and I get an answer about 6.36. 6.36, okay? And finally, let's find z, okay? Ben, sit down, please. Let's find z, okay? So z is sitting right here, angle z. Well, angle z is easy. Angle z is the easiest one of all to find because the angles must be equal. There's no proportions. Angles absolutely have to be equal, okay? Price, you're distracting kids, okay? So angle z, angle A, which is equal to z, has to be 45 degrees. That's what z is, which is 45 degrees, okay? Now, let's find the perimeter of each polygon. Well, I can do that now. So I can add them all up. So the perimeter of the small one, let's add the perimeter up. So I'm going to start here. I'm going to go 3 square root of 2 plus 2 plus 1 plus 1 plus 2. Okay, there's my perimeter. I'm going to add all those numbers up. I've got 2, 3, 4, 5, 6. I've got an answer of 6 plus 3 square root of 2. And that's for the perimeter of A, B, C, D, E. And then the perimeter of the other, well, let's see, let's put these numbers. I know that's 1.5. That was 1.5. And I know this was 9 square root of 2 over 2. So if I start here, the other one is going to be 9 square root of 2 over 2 plus 3 plus 1.5 plus another 1.5 plus 3. If I add them all up, it's going to be 3, 4, 5, 6, 7, 8, 9 plus 9 square root of 2. Okay? Now, here's a biggie. Listen. This makes sense. Here's a biggie. I've got 2 biggies you need to listen to that you will probably miss on your next test because you're not paying attention. Okay? Ben? The perimeters are also going to be in the exact same scale factor. This one is 1.5 times bigger than this one. And that's what our scale factor is 1.5. 1.5 is our scale factor. This triangle is 1.5 times bigger than this one. And that makes sense because if the sides are that much bigger, then the perimeter should. Okay? So the ratio that we found of 3/2 or 1.5 has to be the same ratio between perimeter to perimeter. Now, area is different though. So let's find out what the area of these things are, okay? To find out the area, okay, you gotta watch. For me, the easiest way to find these areas, check it out, is I'm gonna make this into a triangle and I'll cut out the square. Does that make sense? Find the area of this triangle and I'll cut the square. So the area of this triangle, let's find area, is gonna be 3 times 3 divided by 2, because to find the area of a triangle is base times height, which is going to be 4.5. But then I cut out this square, cut out the 1, so I get the area of this triangle to be 3.5. So the area of the one triangle is 3.5, okay? Now, the other triangle, I'll do the same thing. Watch how I do this. If I take a look at the triangle, if I want to find the area of this triangle, it's going to be base, which is 4.5, times height, which is 4.5, divided by 2. Okay? So 4.5 times 4.5 divided by 2. I get an area of 10.125, but I'm going to subtract out the square, which is 1.5 squared, right? 1.5 times 1.5. Let me do that real quick. 1.5 squared. So this square is a 2.25. I'm going to subtract it out. 2.25, okay? So I'll take my 10.125 and I'll subtract out my 2.25. And this one I get an area of 7.875, okay? Now, big idea. Listen, big idea. You won't see this unless you hear it. Even Cody won't see it unless he listens, because Cody's pretty smart. Now, the perimeters were as big as the scale factor. This one really is 1.5 times bigger. That's my scale factor, right? The area. Now, when we do area, we multiply base times height, right? So the scale factor of this is 3/2 squared. That's my new scale factor, which is 9/4. So, you ready? That's my scale for area. Because when I do area, I've got to do length and width. This is exactly 9/4 bigger. In fact, I'll show it to you. I took my 3.5 and I multiplied it times my 9/4. I get my answer. I get the area I found. Okay, I'm almost done. Almost done. So, here's what we do. Okay, almost done. You listening?
Listen.
Chewie, you listening? Chewie, you listening?
Yes, I'm listening.
Thank you. Boys, Luke, you listening?
Listen.
Okay. Now listen, there's 3 things you need to know. Ben, go outside. Honestly, just go outside. You don't think that disrupts what I'm trying to do? So, if 2 things are similar, then the angles have to be equal. The angles are equal, the angles are equal. To make them have the same shape, the angles are equal. But if they are similar, then they're going to have the same proportion. One might be twice as big, or maybe 3 times as big, or maybe half as big, or maybe even 2/3 as big, but they are proportional, okay? The perimeter doesn't change the ratio because the perimeter is going to take the sides to the sides, but the area does change. The big key to the area is this. Whatever the ratio is, the area is going to be the square of the ratio, okay? So if the ratio is 3:2, then the area ratio in this case is 3:2 squared. 94ths. If the ratio happens to be 2 to 1, then the area ratio would be 2 to 1 squared, or 4 times as big. If one object, the sides are twice as big, if the sides are twice as big, the area is going to be 4 times as big, okay? And that's all I have. Now, we've got a couple of things to do. Okay, stop this.